Hello everyone. So today I'll be going over the solutions to Codeforces round 811. Let's get started. And this will only be questions A through C plus E because D was considerably harder than E and around 1,000 other people agree with me. And yeah, let's just get started with problem A. So you're given the time Vlad goes to bed, which is denoted as capital H hours and capital M minutes. You're also given an integer n, and then for the next n lines, you're given lowercase h and lowercase m, which denote the hours and minutes the alarm bell rings. And once you look at the pattern and the problem statement a couple times, you'll start to realize that all you need to do is find the minimum distance between the alarm bells and also when you sleep or when Vlad sleeps. And when I say distance, I mean this number subtracted from this number subtracted from this, and this number subtracted from this, whichever is closest to 0. But the first step to like any problem that uses time is to convert the hours into minutes. So all you do is just take the hours, which in this case, in this time, this would be read as 12:30, and you take the 12, which is the hours, so this would be h, which would be hours, this would be m, which stands for minutes, and you take the hours, multiply it by 60, and then you add on the minutes, and that would be 750 total, because if you do 12:30 as in the time, you want to multiply this number by 60 in order to get the amount of minutes, because hours and 1 hour is just 60 minutes. So 12 hours would be 12 times 60. And then you add this would be 720, I believe. And you just add this with normal 30 minutes. That's all you did. Oh, sorry. And that equals to 750. So that's the first step. You convert all of these into solely minutes. You convert this to minutes, and all that. And then next, we take each of these and subtract this with this. And one test case that you need to look out for, or actually a couple test cases you need to look out for, is first of all, in this test case where the time you sleep, which is 6 a.m., that's kind of odd, but who am I to judge? When that is equal to the time you wake up, which is also a bit odd. Who sleeps and then just wakes up right when you sleep? And then in this case, the answer would be 0, 0, because you sleep for 0 hours and 0 minutes. And another test case, which is harder to implement, is when the time you sleep is larger, like when the number is larger than the time you wake up, than all your alarm clocks. So, for example, let's say you sleep at 22 o'clock in military time. And so in regular time, or however you call it, that would be 10 p.m. So let's say 22 o'clock is when it's an ugly S. So that's when you sleep. And then you also have 2 alarms, one at 3 o'clock a.m. and another at 4 a.m. So the first step, convert them to minutes. 180, 240, and this would be 1,320, I believe. Yeah, I think so. Okay. But now you notice that usually we take this number and subtract this, or sorry, this number rather, and subtract this by this number. But in this case, that would give you a negative number, but you can't sleep for a negative amount of time. So what do? You add 24 hours or 1,440 minutes to that difference, like the difference between 180 and 1,320. And then that will give you the amount of hours you sleep. So to show you this actually works, let's take the minutes, 180 of the alarm clock, and you subtract that with 1,320, which is the time you sleep, and then that will give you, that would be 1,140, I believe. Once you do that, you add, but that would be negative, yeah, sorry. I forgot to put a negative notation. That's negative 1,140. And then now what you do is you add 1,440, also known as 24 hours, and this would give you 300. 300 minutes to hours is equal to 5 hours. And to show this works, let's write it down from 22, which is 10 p.m., 11 p.m., sorry, that's pretty bad, 11 p.m., midnight, 1 a.m., 2 a.m., 3 a.m., 4 a.m. So 5 hours or 300 minutes between 22 to 3. So that would be 1, 2, 3, 4, 5. What do you know? It's correct. And yeah, so the reason why it works is if it's negative, so like let's say you sleep, okay, let's draw a number line real quick. I think this will be a better demonstration. So you sleep at this point and you wake up at this point. So this would be 3 and this would be 22. So if the negative portion, if the part you subtract is that would be, yeah, if the part you subtract is just this, like the negative version of this, because the alarm minus the time you sleep is equal to negative, so it would be this area in this like gap. If you add 24 hours to it, it covers the gap that I was talking about, and also this portion, which is between the gaps, between 22 hours and 3 a.m., which is exactly what you want. And, sorry, let's assume that this is looped. I think it would be better if I draw the number line in a circle, because time is cyclic. So we have 22 hours over here. We have midnight, 3, 6, and 9 o'clock. So if we start at 22 hours, the distance between this area, which is the alarm bell, and also the time you sleep, would be here, right? That's the area. But that would be negative. And to reverse this, we find the whole area, and then that would subtract this. This would like even out, it would balance because there's positive. Now this is positive. And now all it would do is calculate, wait, I messed that up. Actually, the negative portion is here. And if we bring something 24 hours the whole cycle, then this portion would cancel this portion. This whole thing, the large portion between 22 and 3 would cancel, and we're left with only the direct area between 22 and 3. And that's all it is. I guess I can draw it again, but deleting everything in this getting in the way because it looked kind of ugly. And I'll just move this. So yeah, like I was saying, 3 minus 22 would be this area, but it's negative. And then, so we take 24 hours, which is the whole thing. And you see how this is positive, but this is negative. And then so since one's positive, one's negative, the positive and negative cancel each other out all the way. So the negative gets deleted, positive in this area gets deleted until this area, until this point. And so all we're left with is a direct connection between 22 and 3. Kind of confusing, so just let me know if I should explain it again, or if you want me to explain it again later. Yeah, I guess we can move on to problem 2. Problem B. Remove prefix. So you're given a whole bunch of numbers, and your task is to remove elements in the front until all the elements that are left are distinct, meaning there are no repeat elements. Yeah, this problem kind of sucked. Like the way I solved it kind of sucked, and I felt bad about it later because it's such an easy problem, like way easier than problem A, but then I just fumbled the implementation. But it's okay. Practice makes perfect. And yeah, so we remove elements until all elements are distinct. And you remove only from the left. So meaning you start at element 3 in the first test case. We're looking at this array. You start at, let me make it bigger if you want. So this array. So we start at element 3, but then 3 is not distinct because there's another 3 over here. There's a repeat element. So we remove this 3. Now we're on to 1. 1 is distinct, and now we go to 4. 4 is distinct, 3 is distinct. You're good. For this test case, 1, 1, 1, 1, 1. 1 is not distinct. 1 is not distinct, so we delete this. 1 is not distinct, so we delete this. And now we're left with this one, but there's 2 ones left. This is not distinct, so we delete this too. So we just delete everything from the left until there's not any repeat elements. And the solution to this is extremely simple. We reverse the array and we look until there is a repeat element. There's multiple ways to do this. You can use a map, but I decided to use a set. All you do is input the elements and then look at it backwards. And then so we start at this 3. And when I mean backwards, I just start at this 3. So let's say we're given the array 3, 1, 4, 3, which is the first test case. 3, 1, 4, 3. We start at this number, this element, the last element in the array, and go backwards to the first. If there's ever a repeating element, if an element ever repeats, we know to terminate that search, and the element right before is the element that's left. So, for example, we start at element 3, check if it's been seen before. Have we seen it before? It's the first element, so no. And we keep going because we haven't seen it before. We go to 4. Have we seen it before? Nope. It's distinct. Keep going. 1. Have we seen it before? Nope. It's distinct. Keep going. Have we seen this before? Yes, we have. We saw it in the first element over here. That's an ugly arrow. We've seen it here. So we kick this out, and all we have is this. And so we output 1 because that's how many we have to remove. We removed 1 element. And just again to explain why this works is all the problem's asking for is removing elements until the elements that are left are distinct. But then the thing is, what we can do to make this easier for ourselves is look backwards. Because as soon as it's not distinct, we know that whatever we've already searched is the answer. Or is what we have to consider. And yeah. Oh, actually, I remember. I didn't actually look at the code for problem A, so let me do that for you real quick. Sorry about that. So what I do is I input uppercase H and M and also N, and then for each N, I also created capital mins, which means the minutes of like the larger of the time they sleep, of the uppercase letters, of the time Vlad sleeps. And yeah, this is the part I was talking to you about. Always convert it to minutes. So that's what I do. And for each N test case, I also input H and M and then find the minute conversion for it. I set the variable diff or difference to be the lowercase mins minus uppercase mins, which means like this minus this, which is the part I was telling you about where you subtract it to find the difference between the alarm clock and the time Vlad sleeps. And if that number is negative, which is that test case with the 10 p.m. one and the 3 a.m. one, then you add 24 hours or 1,440 minutes. And also answer, you find the minimum answer. And then after that, once you found the answer, you output the hours, and it's divided by 60 because you take the minutes, and then once you divide it by 60, then you get the hours. And then after that, you mod it by 60 because whatever the remainder is, then that would be how many minutes you have. So yeah, that's just the code. And now to go to problem B, resume problem B. Yeah, so all you do is check for distinct elements, and as soon as there's not a distinct element, you disregard it. And yeah, let's look at the code. What I did was first create the array and then inputted everything. So now I got this settled. I created a set, and what a set is it's a standard template library data structure, and then it contains elements and it stores elements, and you can check if an element is in a set in, I believe, log n time by using set.count, and you insert elements into the set using set.insert a sub I. And as soon as there's a duplicate, as soon as an element isn't distinct, you break. And notice how I set I, the first iteration, to n minus 1, and the last iteration, assuming you never break, should be 0, because you're going from right to left. And yeah, as soon as there's a repeat element, a duplicate, you break and otherwise you insert that element to a set and you add to the count. And the reason I'm doing adding to the count is you want to find out how many you remove. So each count would be how many you don't remove. So for example, notice how if there's a duplicate, I don't add it to the count, and otherwise if it's distinct, I add it to the count. So let's take the first test case into account. And then so for the first element, since we're going from right to left, you add this to the set, and since it's distinct, like we mentioned in my OneNote drawing, it's distinct, so you add 1 to count. So count is now equal to 1. 4 is distinct, count is now equal to 2. 1 is distinct, count is now equal to 3. But look, 3 is already seen over here. So this is not distinct, and you terminate the search. So count is only equal to 3 and not 4. So now that we know that count is equal to 3, which is this distinct elements, the answer would just be the size of the array minus the number of distinct elements starting from the right. Because n is equal to 4 and the distinct elements is equal to 3, if we subtract 3 by 4, then we get 1, which is how many we need to remove. I think this test case might illustrate it better, so let's do this. Or sorry, this one. So we start at 1, and then we check if it's distinct, which it is. We check if 2 is distinct, which it is. And again, distinct meaning it's never been seen before. It's the first element that we've looked at. So yeah, 2 is distinct because we haven't seen a 2 before. 1, oh wait, but we've seen 1 over here. And so count is only equal to 2 because there's only 2 distinct elements starting from the right. And yeah, we terminate the search, and then we do 7 minus 2 because that would be however many left over here, because the total elements minus the number of distinct elements would equal to the number of elements that aren't distinct, that we have to remove in order to get an array that's only distinct. And that's what the answer is, 7 minus 2, which is 5. Pretty simple. Now moving on to question C. Minimum varied number. I remember seeing a problem similar to this, so this problem wasn't too difficult for me. And it shouldn't be too difficult because t is quite a small number and also s quite a small number, but yeah. So in this problem, all you need to do is find out, like, build it like iteratively. So you start at like 9, and then, or you start at the last number and then you build it this way, because we're trying to find the smallest number that all their sums is, the sum of all their digits is the smallest. Sorry, let me rephrase that. Okay, we want to find the smallest number where the sum of all their digits is equal to s, which is this, and also all their digits are distinct. Yeah. And so the trick to doing this is find out the minimum, which is either 9 or like s, and then we keep subtracting s. Like, for example, let me delete this. So we're given 45. So we build this backwards, starting at the last digit, because in order to create a smaller number, we have to get rid of all the bigger numbers. We want to see how many big numbers we can get rid of before we get to a small number. So we set x to equal to 9, and we use as many big numbers in the front as we can in order to get rid of them. So we do the maximum of, so each digit would be the maximum or the minimum of x and also s, and then you subtract s by that, and then until s is equal to 0. And I guess it would be easier to see with code because this problem can get confusing. So what you do is, while x is larger than 0, as soon as x is equal to 0, you terminate the search. So yeah, while x is greater than 0, you start at the last digit. I do push back because eventually I flip it. So I go like opposite direction, which is the last digit, and then work my way backwards in order to rearrange it. So this is actually, the first iteration of this would be the last digit. The second iteration would be the second to last. So, like, to show you what I mean, assume like this is the answer to the problem. 1, 2, 3, 4. I would construct it as 4, 3, 2, 1, and then flip it, so that would be 1, 2, 3, 4. And the reason I do this is so that I can find the maximum number. And yeah, what I do is while x is larger than 0, I push back into the vector the smallest number, either s, which is the current value, or x. And x is set to 9 because that's the largest I can put. And then if the minimum is x, so if x is less than s, then I subtract x by s, and otherwise I subtract s by s. And then I also do x minus minus to find the next, because each element has to be distinct, I have to go to the next largest. And yeah, you can see why I'm doing this. Let's use, how about this test case, 20. So we're given 20. And x is set to 9. What we do is, so s is equal to 20. I push back the minimum of either 20 or 9. And so that would be 9. So we push back 9 into the array. So you saw on the answer there's 3 slots, so I'll just draw it out. So we push back 9. So now 9 is in the first slot. And after that, if 9, since x is the smaller one, since the minimum of x and s is equal to x, meaning x is less than s, we subtract x from s, so s minus equals to x, and so s is now equal to 11, because we already used 9, and the sum of our digits should be equal to s, so as soon as we use 9, we, first of all, can't use it again, which is why I do x minus minus, because we can never use x again. And also, we want to do s minus equals to s. Or, sorry, s minus equals to x, because we, the sum is, already used. 9 is already used in the sum. And yeah, we repeat this process again. The minimum of now 11 and 8. So instead of 20 and 9, it would be 11 and 8. Why isn't this telling me? Okay. 11 and 8. And so that would be 8. So now x wins again. And x is pushed back. And then 11 gets subtracted to now 3. Because 11 minus 8 is equal to 3. And now we do the minimum of 3 and 7. And where I got 7 from is x was 9, and then it got minus minus to now 8, and then it got minus minus to now 7. So that's where I got 7 from. Because we used 8 over here, and now it's 7. And now the minimum is finally s. We subtract s by s, and whenever you subtract something by itself, it equals to 0. And now, since s is equal to 0, we terminate it and print everything backwards. So we do 3 and 8 and 9. So we flip it to 389. And the reason we do this is right now this is the maximum number we can get, and by flipping it we get the minimum. So that's what this is, 389. Perfect. Moving on to question E. This was kind of a hard problem. Yeah. So you're given n integers, and then what you have to do is find out if every element in the array can be equal to the same element. So if you can turn all the elements in the array equal to the same element, and yeah, the challenge is probably like the time complexity and figuring out the pattern, but I'm here to explain that. So, okay, two things to notice. First off, oh yeah, I forgot to explain. The way to make it equal, the way to change the elements in the first place is to do a sub I plus a sub I mod 10. So that would be, yeah, if it were 6, then you do 6 plus 6 mod 10, and 6 mod 10 is just equal to 6, so that'd be 12. That's all you do. So yeah, two things to notice. First of all, if you have a number that modded by 10 is equal to 0, you can't move anymore. So let's say we have 40. 40 mod 10 is equal to 0 because it's divisible by 10. And now you can't move anymore because the one move you can do is 40 plus 40 mod 10. And let me explain modulo real quick. So what modulo is if you have a number mod something, it's the remainder of it. So let's say we have 6 mod, this is mod notation, like the percent sign. 6 mod 4 is equal to 2 because we do 6 divided by 4, which is equal to 1. And then if we do the remainder of that would equal to 2. So there's 2 remainder. Because once you do, let me find a better solution. How about 14 mod 4? That would equal to also 2, because 14 divided by 4 is equal to 3. But then the remainder of that, so if we do 3 times 4 is equal to 12, and 14 minus 12 is equal to 2. So it's just, I guess, repeatedly subtracting 4 until you can't anymore, and that's the answer. So 14 minus 4 is equal to 10, 10 minus 4 is equal to 6, 6 minus 4 is equal to 2, and 2 minus 4, which you can't do because it's negative, so it's just 2. And if something modulo something is equal to 0, if a number modulo another number is equal to 0, it means that first number is divisible by the second number. So yeah, if you have a number divisible by 10 and you add that to 40, you still get the same number. This is an infinite loop. So you want to terminate when that happens, or else you'll crash or something. So what we have to do is, in this case, we have to terminate it because if 40 is, or if a number is divisible by 10, then it'll equal to 0. Like this parentheses, the inside parentheses is equal to 0, and then you get 40 again, and it'll create an infinite loop. Yeah. And the other case we need to watch out for is if it's equal to 2, if the number modulo 10 is equal to 2, then it'll also create another infinite loop because 12 plus 12 mod 10 is equal to 14. 14 plus 14 mod 10 is equal to 18. 18 plus 18 mod 10 is equal to 26. And 26 plus 26 mod 10 is equal to 32, I believe, yeah. And then it repeats because now we're at 32, and then now you see that whenever there's a 2 in the tens place, it repeats. But one thing we can get out of this is that throughout this journey, it has been added, like the numbers have added a total of 20. And that's a very important pattern that you need to recognize. And yeah, let's look at the code. Let me actually open it in another tab, just in case we want to look back. So yeah, you input n, you create an array, and then you input the arrays, the elements of the array, and while the element is not divisible by 10 and not divisible by, when divided by 10 is the remainder is not 0 and the remainder is not 2, then you can do the move that you can perform. And when it is, you terminate, and it's inevitable. And what this does is it checks every element, and if that element is divisible by 10, then like this boolean value turns on. And what this is, it's a or equals to and bitwise or. So this is a bitwise or. I've probably seen like the plus equals to, which is like it adds this number to the current value of this, but this is or equals to. And what or is, without going too much in depth into bitwise operators, is so 1 is equal to true, 0 is equal to false. Or what it does is if at least one bit is turned on, so if at least 1 is true, then the total would be 1. If and only if both bits are turned off, then it's 0. Otherwise, it's always on. So like it would be 1 and 1 for this. So if there's 1 and 1, then there's at least 1 1 in this. So it would be 1. So what this does is it checks if it's 0, and if it is, then this becomes 1, and it can never turn off. So once it is, it never turns off. Otherwise, all the elements in the array cannot be divisible by 10, or else this would equal to 0. This would equal to 1. And yes, if it's equal to 1, that means we're at that test case, the first test case that I mentioned, where you're like stuck there. You can only add 0 because a number that's divisible by 10 plus that number, so this case, a number divisible by 10 plus 0, because this is always going to be 0, is equal to this number, the same number, an infinite loop. And yeah, so because there's an infinite loop, then all elements in that array must be equal, or else the conditions isn't satisfied. So we just check all the elements in the array, and what this does is just checks the elements in the array and checks if they're all equal. And if they aren't, then we output no, and otherwise we output yes and continue. And then if we continue, then we assume that the answer is yes, but as soon as there's a cycle in it, that means okay, so the answer is always yes, but as soon as the difference between them, like the modulo, is not 20, then you output no. So let me draw it out for you because it's extremely confusing. Let me not delete that. Okay. So what we do is we take cur to be the first element mod 20, and then if all of them have the same answer when modded by 20, then we know that the answer must be true. And this ampersand is a bitwise or, bitwise and, sorry, which is different from the bitwise or slightly. So a bitwise and must have both bits turned on in order to work. So this is 0 and 1. The result of this would equal to 0 because not both bits are turned on. For this one, it would be 1 because both bits are turned on. You see? So that would essentially mean that all the elements must be, modded by 20 must be the same. And if they are the same, if all elements modded by 20 are the same, that does mean that we're able to create a like same element array, because that's this thing that we're talking about. Because 32 mod 20 is equal to 12. 12 mod 20 is equal to 12. So if we have 12 and 32, we know that the array can be equal, like all the elements can be equal by following this cycle. But if we have something like 42 mod 20 is equal to 2, not 12. And we know that we can't reach 42 ever. And so all of them modded by 20 must equal the same thing. That's just what this does. And yeah, so that's it for the solutions. If you have any questions, please feel free to ask. And yeah, if you liked it, please consider subscribing and liking, and comment down if you have any suggestions and anything like that. And thanks for watching.